Hello students, in today's lecture, we will discuss probability, NCERT miscellaneous examples and exercise. This is disclaimer. So first we will discuss miscellaneous examples 22 to 24. After that, we discuss miscellaneous exercise, question number 1 to 30. So let's get started. In this example, we have colored balls. Colored balls are distributed in 4 boxes as shown in the following table. Okay, so look at the table very carefully. And then a box is selected at random, and then a ball is randomly drawn from the selected box. The color of the ball is black. So what is the probability that ball drawn is from the box 3? So first of all, think about what is the probability it came from the back box 3. Okay, so first of all, try it yourself and then see solution. So let's start the solution step by step. First, let A, E1, E2, E3 and E4 be the events as defined below. The event A represents a black ball is selected. E1 represents box 1 is selected. E2 represents box 2 is selected. E3 represents box 3 is selected. E4 represents the event box 4 is selected. Since the boxes are chosen at random, so therefore probability of E1 equals probability of E2 equals probability of E3 equals probability of E4 equals 1 by 4. Also, probability of A given that E1, that means probability of A when E1 event probability happened equals 3 by 18. Okay, and probability of A given that E2 is 2 by 8, and probability of A given that E3 equals 1 by 7, and probability of A given that E4 is 4 by 13. Now probability of box 3 is selected given that the drawn ball is black is probability of E3 given that A. So by Bayes theorem, probability of E3 given that A, this is equal to probability of E3 times probability of A given that E3. Okay, divided by probability of E1 times probability of A given that E1 plus probability of E2 times probability of A given that E2 plus probability of E3 times probability of A given that E3 plus probability of E4 times probability of A given that E4. Now substitute the calculated values into the formula, and then we will get this is equal to 1 by 4 times 1 by 7 divided by 1 by 4 times 3 by 18 plus 1 by 4 times 1 by 4 plus 1 by 4 times 1 by 7 plus 1 by 4 times 4 by 13, and this is equal to 0.165. Now let's look at next example. So in this example, we have given that A and B throw a die alternatively till one of them gets a 6 and wins the game. Find their respective probabilities of winning if A starts first. So first, try it yourself and then see solution. So let's start the solution step by step. So first, let B denote the success, getting 6. Okay, and F denote the failure, not getting a 6. Thus, probability of S is 1 by 6 and probability of F is 1 minus 1 by 6, which is equal to 5 by 6. Then, probability of A wins in the first throw is basically probability of S equals 1 by 6. Gets the third throw. Okay, when the first throw by A and second throw by B result into the failures, so therefore probability of A wins in the third throw equals probability of A wins in the third throw equals probability of F S. Okay, and this is equal to probability of F times probability of F times probability of S. So it is equal to 5 by 6 times 5 by 6 times 1 by 6. Okay, and this is representing the chance of each individual outcome, and this is equal to 5 by 6 whole square times 1 by 6. Now, probability of A wins in the fifth row equals probability of F, 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 F 4 times then S equals basically 5 by 6 whole to the 4 times 1 by 6 and so on. Hence, probability of A wins equals 1 by 6 plus 5 by 6 whole square times 1 by 6 plus 5 by 6 to the power 4 times 1 by 6 plus dot dot dot. The expression simplifies by dividing by 1 by 6 by 1 minus 25 by 36. First, subtract the fractions in the denominator. Okay, that is 1 minus 25 upon 36 is basically 11 by 36. Okay, and then divide 1 by 6 by 11 by 36, which equals 6 by 11. So, probability of B wins equals probability of A wins. Okay, the probability of 1 minus A wins. Okay, so probability of B wins is 1 minus probability of A wins equals 1 minus 6 by 11 equals 5 by 11. And this is our answer. So I hope it's clear to all of you. So now let's move to the next example. In this example, we have a machine is correctly set up. So it produces 90% acceptable items. If it is incorrectly set up, it produces only 40% acceptable items. So past experience shows that 80% of the setups are correctly done. So if after a certain setup, the machine produces two acceptable items, find the probability that the machine is correctly set up. So first of all, think about this. How would you approach this example? Okay, and then see solution. So let's see the solution. Here we first let A be the event that the machine produces two acceptable items. Okay, so also let B1 represent the event of correct setup and B2 represent the event of incorrect setup. Okay, so now probability of B1 is 0.8 and probability of B2 is 0.2. So probability of A given that B1 is 0.9 times 0.9 and probability of A given that B2 is calculated by 0.4 times 0.4. So therefore probability of B1 given that A equals probability of B1 times probability of A given that B1 divided by probability of B1 times probability of A given that B1 plus probability of B2 times probability of A given that B2. And now substituting these values into the formula, and then we get this is equal to 0.8 times 0.9 times 0.9 divided by 0.8 times 0.9 times 0.9 plus 0.2 times 0.4 times 0.4. Okay, and after simplifying, you will get this is equal to 648 divided by 680, and this is equal to 0.95. Now let's look at exercise question number 1. Okay, so in this question, we have two events A and B, and such that probability of A is non-zero, then find probability of B given that A. If A is a subset of B, okay, this is first, and then second, we have A intersection B is B. Okay, so first of all, try it yourself and then see solution. So let's start the solution step by step. So it is given that probability of A is non-zero. So A is a subset of B. So if A is a subset of B, it means every element in A is also in B. Okay, this means that the intersection of sets A and B is equal to the set A. In other words, every element in A is also in B. So A is a subset of B. Therefore, probability of A intersection B equals probability of B intersection A equals probability of A. Therefore, probability of B given that A, this is equal to probability of B intersection A divided by probability of A by conditional probability definition. And here probability of B intersection A is probability of A. So probability of A divided by probability of A, this is equal to 1. So probability of B given that A equals 1. So I hope it's clear for you. And now look at second part of this question. So here A intersection B we are taking empty. So probability of A intersection B is now 0. So therefore probability of B given that A equals probability of A intersection B divided by probability of A. and here probability of A intersection B is 0. So 0 divided by non-zero number is basically 0. Now let's look at question number 2. Here in this question we have a couple has 2 children. Then we have to find the probability that both children are males if it is known that at least one of the children is male. Okay. And second question we have, find the probability that both children are females if it is known that the elder child is a female. So first of all, try it yourself and then see solution. So let's start the solution step by step. So if a couple has 2 children, then the sample space is S equals B comma B, B comma G, G comma B, comma G comma G. Okay, so set S contains all possible order pairs where each element is either B or G. So now let E and F respectively denote the events that both children are males. Okay, and at least one of the children is a male. So now E intersection F equals order pair B comma B. Okay, and probability of E intersection F equals 1 by 4. And probability of E equals 1 by 4 also. And probability of F equals 3 by 4. So now probability of E given that F equals probability of E intersection F divided by probability of F, which is equal to 1 by 4 divided by 3 by 4 equals 1 by 3. Therefore, the probability that both children are males if it is known that at least one of the children is male is 1 by 3. Now, look at second part of this question. So here we let A and B respectively denote the events that both children are females and elder child is a female. So here the set A contains one element, that is the pair G comma G, since there are 4 possible pairs in the total. So the probability of A equals 1 by 4. And the set B has 2 elements, G comma B and G comma G. So there are 4 total possible outcomes. So the probability of even B is 2 upon 4, which simplifies to 1 by 2. The intersection of sets A and B contains only one element, G comma G. Therefore, the probability of both A and B occurring is 1 out of 4. Now, probability of A given that B equals probability of A intersection B divided by probability of B, which is equal to 1 by 4 divided by 2 by 4 equals 1 by 2. Therefore, the probability that both children are females if it is known that the elder child is a female is 1 by 2. So, I hope it's clear to all of you. So, now let's move to the next question. In this question, we have given 5% of men and 0.25% of women have grey hair. A grey haired person is chosen at random. Males and females are in equal numbers. So find probability that the person is male. So first of all, think about this. How would you approach this question? Okay, and then see solution. So let's start the solution step by step. So to calculate the probability of a person having grey hair, you divide the number of people with grey hair by the total number of people in the group. Okay, so probability of grey hair equals probability of grey given that male times probability of male plus probability of grey hair given that female times probability of female. So the probability of grey is calculated by adding two products, that is 0.05 times 0.5 plus 0.0025 times 0.5. Okay, and the probability of grey is calculated by adding 0.025 plus and 0.00125, which gives us 0.02625. So apply now Bayes theorem. So probability of male given that grey hair equals probability of grey hair given that male multiply probability of male divided by probability of grey. Okay, so the now substituting these values into the formula, and then we get probability of male given that grey haired equals 0.05 times 0.5 divided by 0.02625. Okay, further simplify it and you will get this is equal to 0.0025 divided by 0.02625. Now simplify the fraction. So probability of male given that grey haired equals 0.025 divided by 0.2625, which is equal to 25,000 divided by 26,250. So probability of male given that gray haired equals 20 divided by 21. Therefore, the probability of a gray haired person being male is 20 divided by 21. So I hope it's clear to all of you. So now let's move to the next question. In this question, we have a random sample of 10 people is taken. 90% of people are right-handed. So what is the probability that at most 6 of a random sample of 10 people are right-handed? So first of all, think about this and then see solution. So let's start the solution step by step. A person can be either right-handed or left-handed. So it is given that 90% of the people are right-handed. So probability of right-handed, that is denoted here P equals 9 by 10. Then probability of left-handed, that is here we have taken Q and this is equal to 1 minus 9 by 10 equals 1 by 10. Okay. So now using binomial distribution, the probability that more than 6 people are right-handed is given by summation r from 7 to 10, 10 CR p to the power r times q to the power n minus r equals summation r equals 7 to 10 10 CR 9 by 10 whole to the power 4 times 1 by 10 whole to the power 10 minus r. Therefore, the probability that at most 6 people are right-handed equals 1 minus probability of more than 6 are right-handed. Okay. And this is equal to 1 minus summation r equals 7 to 10, 10 CR 0.9 to the power r times 0.1 to the power 10 minus r. Now, let's move to the next question. In this question, we have a leap year. A leap year has 366 days. The question asks for the chance that this year has 53 Tuesdays. So it provides that a leap year is selected at random and wants to know the probability of it containing 53 Tuesdays. So first of all, try it yourself and then see solution. So let's start the solution step by step. First, determine the number of weeks and extra days in a leap year. So a leap year has 366 days. Divide 366 by 7 goes into 366. Okay, equals 52 times 7 plus 2. This means a leap year has 52 full weeks and 2 extra days. So now to list all possible combinations for the 2 extra days, so you should consider every pair of days that can be added, ensuring no duplication and covering all unique pairs. So the 2 extra days can be Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, Sunday, Monday, so there are 7 total possible combinations for the 2 extra days. Okay, so identify now the several outcomes for having 53 Wednesdays. So for a leap year to have 53 Wednesdays, one of the 2 extra days must be a Tuesday. The favorable combinations are Monday, Tuesday, Tuesday, Wednesday. So there are 2 favorable outcomes. So now calculate the probability. Probability P equals number of favorable outcomes divided by total number of outcomes. So probability P equals 2 upon 7. Therefore, the probability that a randomly selected leap year contains 53 Tuesdays is 2 upon 7. Okay, I hope it's clear. So now let's move to the next question. In this question, 4 boxes A, B, C and D contain marbles of different colors. One box is chosen at random and a red marble is drawn. So we need to find the probability that the red marble came from box A, box B, or box C. So each box has a different number of red marbles. So the question asks for the probability of the marble coming from each box given that it is red. Okay, first of all, try it yourself and then see solution. So let's start the solution step by step. First, let R be the event of drawing the red marble. This means that when you draw a marble, R happens if the marble you draw is red. Now, let EA, EB, and EC respectively denote the events of selecting the box A, B, and C. So, the total number of marbles is 40. The number of red marbles is 15. Okay, so therefore probability of R is calculated by dividing 15 by 40, which simplifies to 3 by 8. Now, probability of drawing the red marble ball from box A is given by probability of EA given that R. Therefore, the probability of event EA given R is calculated using conditional probability of EA given that R equals probability of EA intersection R divided by probability of R, which is equal to 1 by 40 divided by 3 by 8 equals 1 by 15. So probability of that the red marble is from box B is probability of EB given that R. Therefore, probability of EB given that R equals probability of EB intersection R divided by probability of R, which is equal to 6 by 40 divided by 3 by 8 equals 2 by 5. Now, probability that the red marbles is from box C is probability of EC given that R. Therefore, probability of EC given that R equals probability of EC intersection R divided by probability of R equals 8 by 40 divided by 3 by 8 equals 8 by 15. Now, let's look at question number 7. In this question, we have a patient has a 40% chance of a heart attack. Meditation and yoga reduce this risk by 30%, while a drug reduces it by 25%. The patient chooses either option with equal chance. Okay, so after a heart attack, find the probability they choose meditation and yoga. So first of all, try it yourself and then see solution. So let's start the solution step by step. First, let A be the event of having a heart attack. Even the event of following yoga and meditation, and E2 the event of adopting a drug prescription. Okay, so these events are used to analyze conditional probabilities such as probability of A given that E1 and probability of A given that E2 to understand how different interventions affect the likelihood of a heart attack. Therefore, probability of A equals 0.40. Probability of E1 equals probability of E2 equals 1 by 2. And probability of A given that E1 equals 0.40 times 0.70 equals 0.28. And probability of A given that E2 equals 0.40 times 0.75 equals 0.30. Now, probability that the patient suffering a heart attack followed by a course of meditation and yoga is given by probability of E1 given that A. So, probability of E1 given that A by Bayes theorem is probability of E1 times probability of A given that E1 divided by probability of E1 times probability of A given that E1 plus probability of E2 times probability of A given that E2. Now, substituting the values into the formula, and then we will get this is equal to 1 by 2 times 0.28 divided by 1 by 2 times 0.28 plus 1 by 2 times 0.30. And this is equal to 14 divided by 29. Therefore, the probability that the patient followed a course of meditation and yoga is 14 by 29. I hope this question is clear to all of you. So now let's move to the next question. Look at this question. Here we have a second order determinant has 4 entries, each either 0 or 1. Each entry is chosen independently and probability 1 by 2. The question asks for the probability that the determinant's value is positive. So first of all, think about this and then see solution. So let's start the solution step by step. So we have to determine the total number of possible determinants. So a second order determinant has 4 elements. So each element in the set can be either included or not included. Okay, so which gives two choices for each element. So each element can be chosen in two ways, 0 or 1. So the total number of determinants is 2 to the power 4 equals 16. Okay, this means there are 16 different determinants in the table. So now to identify determinants with a positive value, look at the determinants value and check if it is greater than 0. So if it is, then that determinant has a positive value. So a second order determinant A, B, C, D has a value of AD minus BC. For the value to be positive, AD minus BC should be greater than 0, which means AD greater than BC. Since ABCD belongs in 0 or 1. Okay, so the only way for AD greater than BC is if AD equals 1 and BC equals 0. So if AD is 1 and A equals, then A equals 1 and D equals 1 also. So if BC is 0, then at least one of B or C must be 0. So the now possible combination for A, B, C, D that yield a positive determinant are 1, 0, 0, 1. Okay, that is 1 times 1 minus 0 times 0, which is equal to 1 is greater than 0. And the second possibility that is 1, 0, 1, 1, and here you can calculate determinant which is positive. And the third possible combination that is 1, 1, 0, 1, that is here determinant 1 times 1 minus 1 times 0 is 1, which is greater than 0. So there are 3 determinants that have a positive value. Now calculate the probability. So probability the value of the determinant is positive is basically number of positive determinants divided by total number of determinants. So therefore probability of the value of the determinant is positive is 3 divided by 16. Therefore the probability that the value of the determinant is positive is 3 divided by 16. I hope this question is clear to all of you. So now let's move to the next question. Now let's look at this question. In this question, we have an electronic assembly consists of two subsystems, say A and B. Okay, from previous testing procedures, the following probabilities are assumed to be known. Probability of A fails equals 0.2 and probability of B fails alone equals 0.15. Probability of A and B fail equals 0.15. So now evaluate the following probabilities. Probability of A fails given that B has failed. Okay, and the second find the probability of A fails alone. So first of all, try it yourself and then see solution. So now we will see the solution. So let's start the solution step by step. So if we calculate probability of B fails, you need to find the probability that even B does not occur. Okay, so we know probability of B fails alone equals probability of B minus probability of A intersection B. So 0.15 equals probability of B minus 0.15. Therefore, probability of B equals 0.15 plus 0.15 equals 0.3. Now, calculate probability of A fails given that B has failed. use the conditional probability formula, that is probability of A given that B equals probability of A intersection B divided by probability of B. Now substitute the values. Probability of A given that B equals 0.15 divided by 0.3. Simplify the fraction and we get probability of A given that B equals 1 by 2. So now calculate probability of A fills alone equals the probability of A filling alone is probability of A minus probability of A intersection B. Substitute the values. Probability of A fills alone equals 0.2 minus 0.15. So calculate the result. Probability of A fills alone equals 0.05. Therefore, the probability of A failing given B has failed is 1 by 2 and the probability of A failing alone is 0.05. Now let's look at question number 10. So in this question we have bag 1 has 3 red and 4 black balls and bag 2 contains 4 red and 5 black balls. So one ball is transferred from bag 1 to bag 2. Then a ball is drawn from bag 2. The ball so drawn is found to be red in color. So find the probability that the transferred ball is black. Okay. So first of all, try it yourself and then see solution. So let's start the solution step by step. First, let E1 and E2 be respectively denote the events that a red ball is transferred from bag 1 to 2 and a black ball is transferred from bag 1 to 2. Probability of E1 is 3 by 7 and probability of E2 is 4 by 7. So let A be the event that the ball drawn is red. So when a red ball is transferred from bag 1 to 2, then probability of A given that E1 equals 5 by 10 equals 1 by 2. So when a black ball is transferred from bag 1 to 2, then probability of A given that E2 equals 4 by 10 equals 2 by 5. Therefore, probability of E2 given that A equals probability of E2 multiplied by probability of A given that E2 divided by probability of E1 times probability of A given that E1 plus probability of E2 times probability of A given that E2. This is equal to 4 by 7 times 2 by 5 divided by 3 by 7 times 1 by 2 plus 4 by 7 times 2 by 5. This is equal to 16 by 31. Therefore, the probability that the transferred ball is black is 16 by 31. So I hope this question is clear to all of you. So now let's move to the next question. Given events A and B have probability of A is non-zero and probability of B given that A is 1, then find probability of find which option is true about the given 4 options. Okay, so first of all, try it yourself and then see solution. So let's start the solution step by step. Probability of A is non-zero and probability of A given that A is 1. So we know the conditional probability formula, that is probability of B given that A equals probability of B intersection A divided by probability of A. It is given that 1 equals probability of B intersection A divided by probability of A. So probability of A equals probability of B intersection A. It implies A subset B, means set A is a subset of set B. Thus, the correct answer is option A. I hope this is clear to all of you. Now, let's look at question number 12. In this question, we have if probability of A given that B is greater than probability of A, then which of the following is correct? Here we have 4 options. So, you have to choose the correct answer from the given options. So, let's start the solution step by step. So, probability of A given that B is greater than probability of A. Okay, this is given to us. This means probability of A intersection B divided by probability of B is greater than probability of A. It implies probability of A intersection B is greater than probability of A multiply probability of B. It implies probability of A intersection B divided by probability of A is greater than probability of B. So it implies probability of B given that A is greater than probability of B. Thus, the correct answer is option C. So now let's move to the next question. In this question, we have given events A and B satisfy probability of A plus probability of B minus probability of A and B and equals probability of A. Okay, then which option is correct among the given options that we have to find? So first of all, try it yourself and then see solution. So let's see the solution step by step. So we have given probability of A plus probability of B minus probability of A and B equals probability of A. So it implies probability of A plus probability of B minus probability of A intersection B equals probability of A. It implies probability of B minus probability of A intersection B equals 0. It implies probability of A intersection B equals probability of B. So therefore, probability of A given that B equals probability of A intersection B by probability of B equals probability of B divided by probability of B equals 1. Thus, the correct answer is B. So option B is here the correct answer. So I hope this question is clear to all of you. That's all for today's lecture and thank you for your attention. I hope this lesson was helpful to all of you.